lesson. Today we're going to look at absolute value functions. And to do this, what we're going to do is start off by looking at a graph of just some old function. This one happens to be a parabola. And what we're going to try and do is create a graph of a related function. And what we're going to do is put absolute value symbols around the graph and say, well, what if we did that? So now take the absolute value of f of x. We're going to ask ourselves, well, what is that graph going to look like? So I'm going to do that right underneath our original. Well, here's what you have to understand. The best way to tackle a problem like this is to remember that f of x is none other than y. So what we're taking is the y values for all these points here, and we're going to take the absolute value of them. If they happen to be positive already, then they just stay unchanged. For example, if we take a point up here, even this point here is 2, 0. Well, when we get down here, that point is not going to move, because when x is 2, its y value of 0, we're going to absolute value that number, and the absolute value of 0 is 0. So that's an invariant point. And in fact, this whole section up here isn't going to change at all, because all these y values were positive numbers already. Same thing if we start over here. We're going to have this part of the graph absolutely unchanged, because these all have positive y values. The ones that are going to be changing, however, all this part down here where the y values are negative. Well, what we're going to do is we're going to absolute value those y values so they become positive. And the effect is as follows. If we take this guy here, the vertex, and use that as a sort of sample test point. This guy here has a x value of 0 and a y value of negative 4. Well, when we put that negative 4 into this, absolute value it becomes positive 4. So I just have to go up to positive 4. That's where that point is now being beamed. And so similarly, all these other points are now going to have positive y values, and we're going to get this kind of a reflection over the x-axis. So it's kind of a funny looking little graph, but that's what it is. This is the absolute value of f of x. Okay. Let's look at another example, and we'll maybe make it a little bit more involved. Okay. The graph this time is going to look something like this. Kind of a funny looking graph. What we're going to have do, I think, is something like 2 to the left and down 2. We're going to do a little kind of a curved part here, sort of go like this. And then on the right part of it, we'll go 1, 2, 3, 4. And maybe we'll go up a couple units here. So we've got kind of a funny little shape like that. Okay, so that's our f of x. This time I'm going to do something different. This time I don't want to graph the absolute value of f of x. I'm going to try and graph f of absolute value of x. So I'm putting my absolute value symbols only around the x. Now, this one can be a little bit tricky. So again, I'm going to draw everything right underneath, see what we're going to get. Now, certainly when x is a positive number, for example, if I'm looking at this point here, well, when x is 1, we have a y value that looks like it's maybe a little bit bigger than 1 or something like that. So when I put the 1 in here and I take the absolute value of that 1, it's not going to change at all. It's already a positive number, so essentially f of absolute value of 1 is the same thing as f of 1. They behave exactly identically. So all of these this zone here, where all the x's are positive numbers, there's going to be absolutely no change. We're going to get all the same stuff happening that we've seen. Okay, so we got a little curve section, duplicated, so to speak. Where the strange stuff is going to happen is what happens when we go over to the negative numbers. Now, to try to make some sense of that, what I'm going to do is a bit of a sampler here. Let's say I was going to plug -2 in. Okay, so that's my x value. Okay, we want to see what happens when we plug in an x value of -2 into the function. So in it goes f of, now I'm supposed to do absolute value of this x. Okay, so absolute value of -2. Okay. Now, what does that sort of transform into? Well, it becomes f of normal +2. Okay, because the absolute value of -2 turns it into +2. So now I have f of 2. And I go, well, what would be the y value that corresponds to f of 2? Well, I can read that off my graph. Here's f of x. And when I plug in a 2, I get a y value of 2. I can just read that off my graph. So, what am I getting as a y value here? Well, this is going to equal 2. But remember, we started with an x value of -2. So if I plot this point when x is -2, it now produces a y value of +2. That's very different from what we had up here. Now, if I take another point and kind of follow how it's transformed, let's try an x value here of -4. Okay, so I'm going to follow the same little transformation. This time I'm starting with -4. Where's that going to go? Okay, well, I plug it into my function. Absolute value of -4 turns it positive. It's now +4. F of +4, according to my original graph, says, well, when you have a +4, the y value is 0. So this equals 0. But we started with -4. So where's this point going to be? Well, it's going to be over here, -4, 0. Now, you could do this with as many points as you like, but I think you'll agree what you're going to get looks like this. Basically, you're getting a reflection, a duplication of this part, the positive part of your graph, flipped across the y-axis and duplicating over here. As far as this little bottom curve part, that just totally disappears, because you never get negative x values behaving in this function again. They get turned positive, and so everything behaves like positive x values. Okay, so that's kind of our funny looking graph. All right, let's just do one last example here where we do a couple of things at the same time. We're going to do some reciprocal stuff and we're going to do some absolute value stuff all in one. And how do we handle that? Okay, so let's see what we got here. Okay, this example looks kind of like so. Let's see. I think I'm going to start over here, -1 and down a couple. So start down here, and we'll go roaring up to there with a nice little straight line. Okay, and then I'm going to do a little curved part just to make it different. Something like this. Maybe go up to y value of 1. Alright, it's supposed to be more curved there. It doesn't really matter. We get something like that. We're going to call that f of x. Okay, so now what are we going to try and graph here? Well, we're going to try and graph something like this. 1 over the absolute value of f of x. Okay, so this time I've got a little bit of reciprocal stuff going on, and I've got the absolute value stuff of my function. How do I handle that? Well, we're going to draw our little graph right underneath and put the pieces of the puzzle together. Now, first of all, reciprocal. Whether this is turned positive or whether it's negative doesn't make any difference. When it's 0, I'm going to have an undefined, which means a vertical asymptote. So this guy here would be a very good place to start. All right, there we go, vertical asymptote. So now I'm just going to do a couple of these sections. Maybe I'll start with a positive section here. All these numbers are positive in their y values. So the absolute value of these already positive numbers makes absolutely no difference. So in my mind, for this zone here, I'm only really thinking about the reciprocal aspect of this. So I'm looking at, well, let's see, here's an invariant point because it has a y value of 1. So when I go 1 to the right, I want to go up 1. That point will be on my graph here as well. All these little numbers here, they're little positive fractions. When they get flipped over, reciprocated, they're going to become big positive numbers. So we're going to have this. The old vertical asymptote, curved graph stuff. And then as these little numbers here progressively get smaller, what are we going to get? Well, we're going to get another curved part. And here we kind of got some clutter going on here. Maybe I'll just draw this over on the other side where I don't have as much clutter. I've got another vertical asymptote here. Look at that. And that's pretty good because then you can see what's going to happen is these little positive fractions get bigger and bigger, so it's going to go roaring back up. Look at that, like a little miniature parabola on its own here, kind of. Okay, there we go, nice and thick. Okay, what about this part here? Well, all these y values are going to turn positive. Okay? But I'm also going to reciprocate them. So they're going positive, and I have to reciprocate them. Well, let's see. Let's grab a couple here just to get ourselves a foothold. Like, what about this guy over here? That's a y value of -2. It's going to turn positive on me, so it becomes 2. And then I'm going to reciprocate it, so it becomes 1/2. So this guy here should be at 1/2, positive 1/2. So that's about here. Okay. What about this guy here? That's a y value of -1. Turns positive, so it's positive 1. Reciprocates, and it stays at 1. So that's guy's going to be there. Now this is a little straight line, so I'm going to take a guess that I'm going to join these guys with a nice straight line here. Okay. Now, what about all these little negative numbers in here? Little negative fractions. Well, they turn positive, and when they get reciprocated, they become big positive numbers. So what I'm going to have happening here is I'm going to go roaring up to that vertical asymptote. And there it is. There's my graph. So this one's the complete works here. You got everything on the go, and it turns out that it is actually quite manageable. You just got to think in terms of there's two things going on. And with that, we'll catch you later.